Hopefully you've had a chance to look at the Tacoma Narrows Bridge collapse, one of the most spectacular failures of engineering and one of the most spectacular bridge collapses in history. And so we've seen that interesting historical video of the collapse of the old Tacoma Narrows Bridge. What does it look like when we go there? Easy to do. We'll just go to Google Earth and let's go to Puget Sound and have a look at the Tacoma Narrows Bridge. And there it is. They've replaced the old span with a two-way bridge, and if we want to, we can actually go in and have a really close look at the Tacoma Narrows Bridge. And this is what we'd be seeing if we actually were on that bridge. There we go. We can have a look out here. There's a nice sunset over Puget Sound. So we can see the bridge today is in great shape. If we do look back at this old newsreel, one thing that we do see is something familiar about the Tacoma Narrows Bridge disaster. Notice the periodic motion that you can see in the base of the bridge. When we look at it as a still photo, notice a shape that's beginning to appear that should look kind of familiar. Here is today's span, and if we were to look at the profile, we notice the wave that I have here. So there's a big idea here. I want you to use this simulation that you'll see linked on the page to try and model the motion that we see in the Tacoma Narrows Bridge. In particular, we're going to be looking at the key properties of the periodic function. So what are you doing with the key properties? So are you increasing or are you decreasing the amplitude? And are you increasing or are you decreasing the period to get the same appearance in the wave on a string simulation as you have in the Tacoma Narrows Bridge collapse? Anyways, that's your job. So let's get to it.